This tutorial is about the basic concepts of fractions, what they are, what they look like, and why we have them. A fraction is a way of writing part of a whole, and it's formed when we divide a whole into an equal number of pieces. Now let's have a look. I've got a representation here of a whole. And let's say we want to divide it into 4 equal pieces. So there we've taken one whole and divided it into 4 equal pieces. So each piece represents 1/4. Now, I've now taken 1/4 away. Now I've removed 2/4. If I take a third, that's 3/4. And if I take the fourth, so I've now got all 4 pieces, I've taken all of them, 4/4, which is exactly the same as taking the whole. Let's just return for a moment to the 2/4. Now 2/4 is exactly the same as if I'd started with my whole and actually divided it into 2 pieces of equal size. And you can see that that's exactly the same as 2/4. So I can write 2/4 as 1/2. Let's have a look at another illustration now. Here I have a bar of chocolate. It's been divided into 6 pieces of equal size. So we've taken a whole bar and divided it into 6 pieces. So each piece is 1/6. Now, let's say I'm going to share my bar of chocolate with the cameraman. So I want to divide the bar of chocolate into 2 pieces. So if I do that, we're each going to have 1, 2, 3, 6. So 1/2 is exactly the same as 3/6. But there's not just one cameraman, we've got 2 cameramen. So I need to share it actually between 3 of us. So now, if I put my bar back together and I need to share it between 3, we're each going to get 2 pieces. So 1/3 is exactly the same as 2/6. But let's say I want to eat all my chocolate bar myself, so I'm going to have all 6 pieces. So they're all mine. I'm not going to share them. So I take all 6 pieces and I've taken away the whole bar. So, fractions we can look at in 2 ways. We can look at it as the number of pieces that we've used divided by the number of pieces that make a whole. Or as the whole divided by number of pieces or number of people that we've divided it into. So here we have a whole bar divided into 6 pieces. Here we have the number of pieces that we've taken divided by the number of pieces that make up the whole bar. Let's have a look at some other fractions. Let's say we have 3/8. So we've divided a whole up into 8 pieces of equal size, and we've taken 3 of them, 3/8. We could have 11/12. So we've divided a whole up into 12 pieces and taken 11 of them. We could have 7/10. Here we will have divided a whole into 10 pieces of equal size and taken 7 of them. And we can have any numbers in our fraction. So we could have 100 500ths or 3 167ths and so on. Now, we've looked at representing fractions using a piece of card, circular representation, our rectangle with our bar of chocolate. Let's have a look at one more before we move on. And let's see it on a section of number line. So let's say we have 0 here and 1 here. So let's look at what 3/8 might look like. Well, I need to divide my section into 8 pieces of equal size. Now, obviously, this is an illustration, so I'm not actually getting my ruler out to make sure I've got equal size pieces, but hopefully that's about right. So we've got 1, 2, 3, 4, 5, 6, 7, 8 pieces of equal size, and I'm going to take 3 of them. So if I take 1, 2, 3/8, that's where my 3/8 will be. Let's have a look at another one. This time we'll look at 11/12. So we need to divide our line up into pieces. So we have 12 pieces of equal size. Okay, so we want 11 of them, so we need to count 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our 11/12 is represented there. Let's look more closely at our fraction 1/2. Now, we've already seen that 1/2 is exactly the same as 2/4, and it's exactly the same as 3/6. Well, it's also the same as 4/8, 5/10, 20/40, 99 198, and so on. We could go on. And what we have here is actually equivalent fractions. Each one of these fractions are equivalent, they're the same as each other. Now, this form of the fraction, our 1/2, is our fraction in its lowest form. And often we need to write fractions in their lowest form. It's much easier to visualise them actually in this lowest form than it is in any other form. So we often want to find their lowest form. Well, let's have a look first at finding some other equivalent fractions. So let's say I take 3/4. How do I find an equivalent fraction? Well, what I can do is multiply the top number and the bottom number by the same number. So let's say I multiply by 2. if I multiply the top number by 2, I must also multiply the bottom number by 2, so that I'm not changing the fraction. 3 times 2 is 6, 4 times 2 is 8. So 6/8 is a fraction equivalent to 3/4. Let's try another one. This time let's take our 3/4 and multiply it by 3. The top number is multiplied by 3, so must the bottom number be. 3 3s are 9, 3 4s are 12. So 9/12 is equivalent to 6/8, and they're both equivalent to 3/4. Let's do one more. This time let's multiply both the top number and the bottom number by 10. So we have 3 times 10, giving us 30, and 4 times 10, giving us 40. So another fraction equivalent to 3/4 is 30/40. So it's very easy to find equivalent fractions as long as you multiply the top number and the bottom number by the same number. Now we have some mathematical language here. Instead of using the word top number, I'll write it down, top number and bottom number, we have two words that we use. The top number is called the numerator, and the bottom number the denominator. Now let's have a look at seeing how we go the other way. When we have an equivalent fraction, how do we find this fraction in its lowest form? Well, let's look at an example. Let's say we've got 8/100ths. Now, we need to find the number that the lowest form was multiplied by and that we ended up with 8/100ths. Well, the opposite of multiplying is dividing. So we need to divide both the numerator and the denominator by the same number so that we get back to a fraction in its lowest form. Well, if we look at the numbers we have here, 8 and 100, the first thing you should notice is actually that they're both even numbers. And if they're both even numbers, then obviously we can divide them both by 2. So let's start by dividing the numerator by 2 and the denominator by 2. 8 divided by 2 is 4. 100 divided by 2 is 50. Now we need to look at our fraction again. We found an equivalent fraction, but is it in its lowest form? Well, again, we can see that they're both even numbers. Both 4 and 50 are even. And so we can divide by 2 again. 4 divided by 4 gives us 2, and 50 divided by 2 gives us 25. So another equivalent fraction, but is it in its lowest form? Well, we need to see if there is any number that goes both into the numerator and the denominator. Well, the only numbers that go into 2 are 1, which goes into all numbers, so that's not going to help us, and 2. Now, 2 doesn't go into 25, so therefore we've found the fraction in its lowest form. So 8/100ths, the lowest form, is 2/25ths. So when a fraction is in its lowest form, the only number that will go into both the numerator and the denominator is 1. Those numbers have no other common factor. Now, if we look here, we can see that in fact we could have divided by 4 straight away instead of dividing by 2 twice. Well, that's fine. If you've noticed that 4 was a factor of both the numerator and the denominator, you could have gone straight there doing 8 divided by 4 was 2 and 100 divided by 4 was 25, and then check to see if you were in the lowest form. That's fine. But often with numbers, larger numbers, it's not always easy to see what the highest common factor is of these two numbers, the numerator and the denominator. So often it's easier to work down to some smaller numbers, and then you can be certain that there are no other common factors. Now, if we take all the pieces of a fraction, like I did with my chocolate, I took all 6 of them. That's the same as 6 divided by 6, and that was our whole. And any whole number can be written this way. So we could have 3/3. If we take all the pieces, we've got 1. 8/8. If we take all the pieces, we've got 1. Now, I'm going to rewrite our mathematical words, numerator divided by denominator, because we're now going to look at fractions where the numerator is smaller than the denominator. And we have a name for these type of fractions, and they're called proper fractions. And examples are a half, 3/4, 1/6, 7/8, 5/10. You see, in all these cases, the numerator is a smaller number than the denominator. And as long as that is the case, then we have a proper fraction. So we can have any numbers, 100, 150ths, for example. Now, if the numerator is greater than the denominator, then the fraction is called an improper fraction. And some examples would be 3/2 or 3/2, 7/5, 8/4. We could have 12/8, or we could have 200 100ths. And in all these cases, the numerator is larger than the denominator, and it shows that what we've got is actually more than a whole one. All these fractions, the proper ones, are smaller than a whole one. We haven't taken all of the pieces. 3/4, we've only taken 3 out of the 4. 1/6, 1 out of the 6. So they're all smaller than a whole one. With improper fractions, they are all larger than 1 whole one. So if we take 3/2, for example, what we've actually got is 3/2. Now, improper fractions can be written in this form, or they can be written as mixed fractions. So let's have a look at our 3/2. And what we can do is put 2 halves together to make the whole one, and we've got 1/2 left over, so that can be written as 1.5. So they're exactly the same, but written in a different form. One is a mixed fraction, and one as a top-heavy fraction, an improper fraction, where the numerator is larger than the denominator. Let's have a look at another example. Let's say we had 8/3. Just move those out of the way. Let's count out 1, 2, 3, 4, 5, 6, 7, 8/3. how else can we write that? How do we write that as a mixed fraction? Well, what we're looking for is how many whole ones we've got there. Well, if something's been divided into 3 pieces, it takes 3 pieces to make the whole one. So that's 1 whole one. There we have another whole one, so that's 2. And we've got 2/3 left over. So 8/3 is exactly the same as 2 and 2/3. Let's look at one more. Let's say we had 7/4. Now, we know that there are 4 quarters in each whole one. So we see how many 4s go into 7. Well, that's 1. And we've got 3 left over. So we've got 1 3/4. Let's have a look at one more. 37/10. Now, we've split something up into 10 pieces of equal size. So we need 10 of those to make a whole one. So we need to see how many 10s, how many whole ones there are in 37. Well, 3 10s make 30, so that's 3 whole ones. And we've got 7 left over. So we've got 3 7/10. Let's just move those. Now, let's have a look at doing the reverse process. So if we start with a mixed fraction, how do we turn it into an improper fraction? Let's look at 3 1/4. And if we look at this visually, we've got 3 whole ones and 1/4. And what we want to turn it into is all quarters. So we have a whole one, and if we've split it into quarters, we know that a whole one needs 4 quarters. So we have 4 there, another 4 there, another 4 there, plus this 1. So we've got 3 4s, a 12, plus the 1 gives us 13 quarters. So 3 1/4 is exactly the same as 13 quarters. Well, let's have a look at how you might do this if you haven't got the visual aid. Well, what we've actually got here is our whole number and the fraction. We want it in quarters. So what we're doing, let's write it again. We're actually saying we want 4 quarters for every whole one. So we've got 3 lots of 4. And then what we're adding on is our 1. And these are all quarters. So it's the whole number multiplied by the denominator. We've added the extra that we have here, whatever this number is, and those are the number of quarters we've got. So we've got our 3 4s are 12 plus 1 quarters, so 13 quarters. Let's have a look at one more example. Let's say we've got 5 2/9. We want to turn it into this format. 9ths. Well, if we want to take a whole one, we need 9 9ths. And we've got 5 whole ones. So we're going to have 5 times 9, lots of 9ths this time. And then we need to add on the 2 9ths that we have here. So our 5 9s are 45, plus the 2, and they're all 9ths. So we have 47 9ths. Any whole number can be written as a fraction. So for example, if we take the number 2, if we write it with the denominator of 1, we've written it as a fraction. And any equivalent form, so we could have 4 over 2, 30 over 15, and so on. So any whole number can be written as a fraction with a numerator and a denominator. So, fractions. They can appear in a number of different forms. You might see proper fractions, improper fractions, mixed fractions, and you can see lots of different equivalent fractions. So they're all different ways that we see them.